Someone just took the architecture of a Wall Street firm and open-sourced it. It's a Python project called Trading Agents, and it crossed 53,000 stars on GitHub this weekend, shipping entirely under a permissive Apache 2.0 license. Look at a traditional trading floor. It is dense with specialized roles and competing data streams. This project replicates that exact chaos, running an entire simulated firm under the hood. The underlying system started as a late 2024 research paper out of UCLA before scaling into a viral codebase. By taking institutional-grade trading mechanics and mapping them directly to specialized AI agents, the authors built a publicly accessible, fully auditable reasoning system. If you want an AI to analyze a stock today, the standard developer instinct is to build a mega prompt. You dump massive amounts of financial data into a single context window and ask the model for a buy or sell signal. That approach almost always defaults to confirmation bias. The model picks an early narrative, aggressively ignoring conflicting data. Asking one model to weigh both sides forces it to play chess against itself, leading to context collapse where reasoning loops inward. Trading Agents abandons the single prompt. It replaces the isolated model with a LangGraph architecture built on distributed, highly specialized agents. By breaking the analysis into a multi-agent structure, the system uses architectural separation to force the AI to confront counterarguments it would otherwise ignore. We can reverse engineer exactly how this framework evaluates a position by mapping its state machine, starting with the raw data intake. The first layer deploys 4 parallel analyst agents. The fundamentals analyst calculates intrinsic value from SEC filings and ratio analysis. The sentiment analyst scores X and Reddit for public mood. The news analyst tracks macro events. Finally, the technical analyst runs MACD, RSI, and pattern detection. These 4 agents run in strict parallel. Each one produces a completely independent written report, and they explicitly do not see each other's work. The system avoids collapsing their findings into a single vector. When the technical charts say buy, but the macro news says sell, that disagreement is actual market signal. Data passes to a central synthesis node, the research manager, which splits it between 2 opinionated researcher agents. Their mandate is strict. One argues for the position, the other against it. Across multiple debate rounds, they fire specific data points to attack each other's logic. The resulting back-and-forth reasoning is aggressive. It forces the models to defend their positions against targeted critique. At the end of the debate, the research manager reads the full transcript. It adjudicates the actual quality of the arguments, rather than just tallying up buy and sell signals. Forcing this adversarial separation extracts defensible logic and strips out the bias that usually plagues large language models. With the debate settled, the pipeline narrows down to the trader agent. Its job is to evaluate the result and determine exact timing and position size. A major update shipped in version 0.2.4 that changes how this final decision is processed: the implementation of structured outputs. By utilizing strictly typed Pydantic schemas, the system forces the language models to return cleanly parsed data, which drastically drops execution failure rates. This update also expanded native integration, bringing in support for DeepSeek, Qwen, GLM, and Azure OpenAI. Because pulling parallel analysis and running multi-round debates burns real tokens, the developers added a checkpoint flag. If a run crashes halfway through, you can resume exactly where it stopped. There is also a persistent memory log that saves every single decision and its underlying reasoning to a local markdown file. On subsequent runs for the same ticker, the system fetches the realized returns, writes a reflection on what went right or wrong, and injects that history back into the prompts. Features like stateful checkpointing and structured outputs move the system toward a deterministic state machine, preserving internal logic and ensuring decision outputs remain perfectly consistent. Before execution, a risk management node evaluates the proposed transaction against volatility and liquidity. It hands off to the final portfolio manager agent, holding ultimate authority to approve or reject. The final output is a standardized 5-tier rating: buy, overweight, hold, underweight, or sell. Because every transition in the graph is isolated, the system is fully auditable. If the portfolio manager rejects a trade, it outputs a traceable written explanation detailing exactly why. An autonomous multi-agent system requires strict final fail-safes and the ability to communicate nuanced confidence intervals over simple binary decisions to actually be reliable. The authors state clearly in the repository that this is a research framework, not financial advice for your retirement account. The simulated exchange acting as the final node is purely a historical backtest environment. It is not connected to a live brokerage integration. While historical backtests on major tech stocks have shown cumulative returns in the 23 to 27% range, that data requires context. Backtests operate in a vacuum. They do not account for real-world market slippage or the execution latency of live trading. The specific value here lies in deep dive strategy validation and architectural research, not in blindly deploying capital. Getting the framework running is a fast process. You clone the repo, run a pip install, set an API key, and start the CLI. The maintainers recently shipped multi-stage Docker support, allowing developers to pull the official image for an immediate cross-platform local deployment. The interactive command line drops you into a picker to select your ticker, your analysis state, and the specific LLM you want to use. To understand the rigorous methodology driving those options, you should pull the original archive paper, 2412.201.38, and read it alongside the codebase. While this specific repository is mapped to a quantitative trading firm, its underlying logic applies anywhere. Parallel specialists, adversarial debate, and layered approval structures are entirely domain agnostic. Ultimately, Trading Agents provides a clean reference implementation for developers looking to integrate complex adversarial reasoning into their own multi-agent systems.